And I'm going to minimize this stuff so that it doesn't, typically it'll show up. So I'm going to turn that thing off. And let's go ahead and get started. So let me maybe minimize that down. Okay. All right. So under AutoCAD, if you have AutoCAD up and running, let's take a look. Go ahead and we're going to just go to AutoCAD and we're going to open up just a brand new file. So we'll be into this view right here. Okay. So the commands we're going to take a look at, the first draw type commands, they occur on this draw panel right here. We have polyline. Under here, we're going to see polygon. And then under this section, we're going to have, there's your point command and there's your donut command. So those are the four that we're going to look at. So let's check out the polyline first. So first off, the polyline, it functions as one object. So let me go over here real quick. So the polyline, as you look at a polyline, if you have a polyline type object, okay, if you have a line group, so if I have draw a line and then another line and another line, okay, if I'm using the line command, these guys are all separate objects. So that's an object, that's an object, that's an object. When you draw a true polyline in AutoCAD, you could draw them right next to each other, as we're going to do tonight. You wouldn't be able to tell the difference between these two guys. Okay, they would look identical. But the one difference is if you would select on this guy, you would find as a line, he would be the only one that would select, even though these guys might be connected. As a polyline, if I select it here, the whole thing's going to select, okay? So that would be one difference. The other thing, in AutoCAD, these guys right here, those are called endpoints on lines, okay? So in a polyline, what you have, these guys right here, these are not called endpoints. They're referred to as vertexes. So we have what's called a vertex, and we have, you know, that's a vertex, that's a vertex, that's a vertex. Polylines also have a definite direction associated with them. So there's a starting vertex and an ending vertex, and so it knows which direction's going on with it. Okay, so lines really don't have that. They just have two endpoints. Okay, so let's go back. We'll look at AutoCAD. So let's go in and we're going to draw a line. So I'm just going to go to the line command, just eyeball a point to a point to a point to another point. Okay, we're going to do the same thing with the polyline. Click on the polyline, point, 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 and point. And when you're done, hit enter. So as you look at these two guys, what you should notice is that these guys really look the same. But if you click on, for instance, the line, you'll notice when you click on the line, the only thing that highlights is that object. Everything else does not highlight. But if I come down here and click on the polyline, you'll notice that the whole object selects. So that tells you right there they're different animals. The other thing, if you look at, this is a vertex, and that's a vertex, and that's a vertex. Notice on the line you have those same things too. They look like vertexes. But this midpoint is different than that midpoint. You notice the look of it's a little different. So polylines have that different look on the midpoint. Okay, kind of everybody seeing that?
Yeah.
So the other thing too, and we talked about this, I believe, last week, is that you can take a polyline and blow it apart. So we can convert a polyline into a line. We'll also be able to take this collection of lines and join them together and convert them into a polyline. So you can go both ways. Polyline back to line, or lines into polyline. The other thing about a polyline, which is somewhat unique, is it can also have arcs attached to it, and they become part of the polyline. So you can think what you have are two types of objects connected, polylines and polyarcs. Okay, so we'll take a look at those. All right, so go ahead, if you want, just select all of your objects, and then you can just hit the delete key, so we'll take those out. So polyline has multiple sub-options, and we looked at one object last week that was a polyline, that was the rectangle, and one of the things we were able to do with a rectangle is give it width. So just to go back and revisit that concept, if we look at width, let me delete this here. when you have a polyline and you have width associated with it, what you have is, here's your vertex, and then what you have, when you give it width, what you're really doing is bringing a line basically kind of out this way. Something like this, and then something like that. So what we have is the actual geometry of the polyline is embedded inside, and then this is your width. So what we got going on here, we know that the width is the distance from that edge to that edge. That's what we call the width. They also have something in a polyline called a half width. So that would be this dimension. That would be my half width. So they're essentially the same animal. It's just one you define with a half and one you define with the whole. So it's kind of like with a circle. You can either talk about its radius or its diameter. The other thing about a polyline's width is that this edge really doesn't exist on that polyline. Really, the only geometry that you have existing is that embedded line on the inside. Okay, so let's take a look at that. So when we go into the polyline command, we're going to click on polyline. We're going to just specify a point somewhere like that. So once you specify a first point, notice now you're getting sub options here: arc, half width, length, undo, and width. And after we add a few more segments, we'll get even another sub command. So we're going to go to width here. And what it's going to want to know is a starting width, because the width can have a starting width value and an ending width value. So these are cool because these are going to allow you to taper it. So you can go from no width to a bigger width, and what you can get is like a cool taper, and I'll show you how to do that. Well, what we're going to do is specify a common width. So don't put a huge value in. Let's make it about maybe 0.25. So I'm going to type in 0.25 for my starting width and hit enter. And notice what will happen. It'll now ask you for your ending width. Starting width and ending width are going to be equal. In this case, if you want that to be, you just accept it. If you want to change it, we can change it. I'm going to just accept it, so just hit enter. So now notice that as you draw, you're going to notice that you see it's just putting the width on it. What you might also notice up here is that that looks really nasty, and what we'll see is when we get out of here, it's going to fix it. So if you just put a few lines down in here and then go ahead and hit enter, you'll notice it now fixed that. It beveled that shut, and it beveled that shut, and it beveled that shut. So those all are good. Okay, is everybody getting that to work?
Yep.
How did you bevel those shut?
Well, it should do it automatically. So when you get out of the
fine.
So when you're in the, are you still in the polyline command?
I'll jump back in. Sorry.
Okay. Once you get out of the polyline command, it automatically does it. Okay.
Oh, yep. All right, we're good. That's what
Okay. So if you you should zoom up now. You see it's beveled shut, right?
Yep.
Okay. So here's the other thing. If you click on your polyline, I want you to notice where is the actual vertex. It's embedded in the center. There's that, and there's that. Okay. And the other thing about it, it's always equidistant. So in our case, it's 0.125 that way and 0.125 that way, okay? So you can't have unequal widths with the width. It's always going to be an equidistant thing. That work for everybody?
Yep.
Okay, so let's go ahead and we'll drop this out. Just click on him and delete him. And what I would like you to do also is go ahead and we're going to do a zoom all. So just type in Z, enter, A, enter. So it'll zoom us out like that. So I want to now talk about the concept of an open polyline versus a closed polyline. So if we think about what we mean by closed polyline, if we look at a typical polyline, what we're saying is I've got a line here to here, and if I draw that back to the starting point, I would say that line is closed. Now, in AutoCAD polyline terminology, you can either have it open or closed, and it can still look like it's closed, such as this, but it won't be unless you use the close option. Then it'll be a true closed polyline. So if we have width on this polyline, we're going to be able to see that. So let's go back here and take a look at this. So what we're going to do is we're going to draw two cases. I'm going to draw two triangles, one where we're going to close it and one we're going to have it open. So I want to go into the polyline command. One thing about this, by the way, once you set the width up, it remembers it. So you still should have your width set, okay? So we're gonna start out with a value of 2,2 and hit enter, okay? Should come on your screen somewhere. Just pick a point, pick a second point. Now we're gonna go back to that starting point. So we're gonna type in 2,2 and then hit enter, and then enter one more time. Now, in this case, we truly have a closed figure because we started at 2,2 and we ended at 2,2, but do you notice how it did not bevel that shut? Does everybody see that? So,
Yeah.
I can see it.
So AutoCAD absolutely thinks this is an open polyline right now, okay? So we're gonna contrast that and show you what a closed polyline would look like. So if I go into the polyline command and I just pick a point, pick a second point, pick a third point, notice down here now there's a close option. If you select that, notice it closes that polyline back and it beveled it shut, okay? So this polyline, if we listed it, it would tell me that that polyline is open. This polyline is considered closed, okay? So there is a bit of a difference in the way AutoCAD looks at that. Did that work for everybody?
Yep.
Okay, great.
Yep.
Fine.
All right, so there's another option in here called length. And what this will do is allow us to specify a length based on a previous segment. So we won't have to give it what angle we want it to go out. It'll just automatically go the angle that it's already tracking. So in order to do this, we're going to go to the polyline command, pick a point, pick a second point. So in this case, we want to continue out this direction, the same direction that this line is right here, but we don't want to specify the direction. We just want to give it a length. So we're going to give it length, and then we can just tell it what distance we want it to go. So I'm going to give it, let's say 5. I'm going to type in 5 units. And notice what it did is it just pushed that thing out another 5 units. It held the same angle, okay? If you give it a negative distance, it goes back on top of itself like that. So you can give it both a positive distance or a negative distance. And let's go ahead and hit the enter key. So I want you to notice what it did. When you click on this, you'll see that it actually established a second line segment. So here's the first line segment from that grip to that grip. And when I did the length of 5 units from here to here is 5 units, okay? If we would explode this line, this polyline down to line segments, I'd actually have 2 segments, one here and one here, okay? Did everybody get that?
Yep.
Now, there's another command we're going to talk about in a couple of weeks into the modify section that is also called lengthen. And it'll essentially do the same thing, but instead of attacking another segment onto it, it would actually push this guy up whatever distance or subtract that distance down. So the difference will be you'll have 1 segment as opposed to 2. Okay, so there's a bit of a difference in how that works. Okay, so let's go ahead and we're going to say erase. So I'm just going to type in E for erase. Oops. Do it again if it did what mine did. Type in erase and then type in the word all and then hit enter twice. And then you can follow that up with a zoom all. Okay, so we just bring them back. So now we're going to take a look at the polyline arc options. So arcs for polylines is just as complex as they were for this type of arc. So you're going to see when we get into this, there's a lot of options. But the one thing that's really cool about the polyline arc is it automatically pretty much goes tangent from the last object. So that's a really nice feature. So if I go into the polyline command again, I can pick a point. The minute I pick a point, notice I'm in what's called the line option right now, but you could go right away to the arc option if you want, but we're going to go hit a second point first. All right, now we're going to go to the arc option. Notice when we go to the arc option, all this menu changes down here. So what you have is angle, center, direction, radius, and second point. So those are all referencing that, that arc right there, okay? So what we have is, there's the endpoint, click on that, get another endpoint, get another endpoint. What you might notice is all of these arcs are tangent to each other, okay? So every arc you're doing is tangent, unless you decide to do one of these other options, like radius or direction. I would change that up, okay? If I want to go back to the line options, then I can just switch back to line. Now notice this is tricky because if I just take this line over this way, it will not be tangent to this arc. But a little trick you can use, if you want this line to be tangent to this arc, you can go into the lengthen option or length, and you can just tell it the length, 5 units, and that line is now tangent to that arc. Okay, and so if I close that, there's my polygon. So again, if I clicked on this, you'll notice that's an arc, that's an arc, that's an arc. If we explode this object, you're going to get those come back as arcs and lines for you. So that would be kind of how that would work. All right, any questions on that?
I'm good.
Arcs are just as hard to use in the polyline as they are out here, so you're probably not going to use that option very often, okay? In fact, there's better ways to do things nowadays. So the polyline is kind of an older type command. You know, you just don't see that used as a command that much anymore. All right, so let's go ahead. If you highlight that, then you can just hit the delete key on your keyboard and that'll take that out. All right, so let's look at one more option. And this option is pretty cool with polylines. This is the ability to give a line a taper. So what I'm going to do is we're going to go into the polyline command and we're going to pick a first point. And what we're going to do is change the width. I want to make that width just a little bit bigger. So instead of being 0.25 as a starting width, let's make that 0.75, okay? Hit enter. Accept the ending width as 0.75. So what we're going to do is we're just going to kind of pick a point, come out like that, and then we're going to go to the arc option. So notice the arc is not tapered. What we're going to do is taper that arc down to a 0 width. So we're going to go into width, accept the default of 0.75 for the starting width, but when it asks you for an ending width, make that 0. And notice now as you drag this guy out, you get a nice tapered arc, and then you can go ahead and hit enter. So that's about one of the only ways you can do that kind of thing when you're talking about arcs and tapering. That's kind of a neat process in polylines. Okay, do you guys get that to work?
Yep.
Okay, so one thing also, the way this looks on the screen, okay, filled in like this, if you send this picture to the printer, it'll fill it out on your printer as well. But I want to show you what can happen. If you're not quite exactly looking straight down on top like this, watch what happens if I move the view a little bit. I'm going to move the view just a hair. I'm not really looking, even though that says top, I'm not exactly top down. Notice what's happened to the look of this polyline. And so what you see here, it's still a filled polyline, but that's the way it looks when it's not looking straight perpendicular onto the plane that it's in. So if you sent this to the printer right now like this is what you'd get, okay? So you always want to make sure you're top down, and that fixes that, okay? So here's another thing with that display. There is a system variable that governs whether this is filled in at any time, okay? So that system variable is called fill, F-I-L-L. So we're going to type in the word fill, F-I-L-L, and hit enter. And this little variable is set to on currently. If you set that variable to off, notice nothing happens, but what we have to do is force a regeneration, a recalculation of the screen. So we're going to type in RE for regen and hit enter. So there's that look that we had before. Even though we're top down, that's what you're going to get. And it doesn't matter which view you look in, it's always going to look like that, okay? So that's a filled polyline with the fill variable turned off. And again, what you see here is what the printer will see, because AutoCAD's what they call WYSIWYG. What you see is what you get. So we're going to turn that variable back on, because if you turn that variable off, it stays off, and you don't want that because it affects other things as well. Okay, so there's a couple of other types of objects that it will affect. So go ahead and type in fill again, turn your fill back on, and type in RE to regen it. Okay, so that affects polylines that have width. It affects other things like hatch patterns, some other objects that we'll see when we get into AutoCAD. All right, questions? Anybody?
All good.
Okay, so we're going to go ahead and we'll just delete this. That's the polyline. So the next object we're going to take a look at is the polygon. So the polygon exists underneath the rectangle here. If you open this up, you'll notice there's your rectangle and there's this guy called the polygon. So let's take a look at this, because this guy has several options. Let me go ahead and delete this. Now there's an option called center point, circumscribed, and then there's an option called center point inscribed, and then there's an option called edge. So there are 3 ways to define a polygon, or a polygon. So the polygon is actually a closed 2D line. That's the one thing to understand about it. So it's kind of like a rectangle. A polygon can be anywhere from 3 sides up to some maximum value. Anybody take a guess what the maximum value for a polygon would be?
250.
250. That's a pretty good guess. It's actually quite low. Theoretically, mathematically, I mean, it could be infinite, all right? But if you had an infinite number of sides, you'd essentially have a circle. So AutoCAD does have a limitation. The limitation is 1024, and that number is a binary number that's actually 2 to the 10th, okay? So that's your limit. So you can go from 3 up to 1024. Also produces what's called a regular polygon. So what a regular polygon means, if you know what we're talking about mathematically, so if you have a polygon, I'm just going to draw a square. That means that the sides all are the same distance, and the angles at each vertex are all the same. So in this case, for a 4-sided, which is a square, it would be 90 degrees, 90 degrees, 90, and 90, okay? So the polygon will generate that. So we have 2 methodologies we can use using a center point. So give me a second. We're going to draw a circle here. Draw another circle. I'm going to try to, it's a little hard to draw using this method, but let me see if I can get this. So the first method is what they call circumscribed. So you have an imaginary circle. You actually won't see the circle, but you're going to pick the center point of the circle, and then what it will do is it'll want to know a radius. So the radius goes from vertex to the center. And notice the way I've drawn this. If this was a true 3-sided type of polygon, the distance that it's asking you for the radius, it's the radius of the circle, but the distance is from the vertex, that point, to the center. This circle is imaginary. You don't see that, okay? So this guy is what we call circumscribed inside of a circle. The other method that you can use is what's called, inscribed. So in inscribed, the circle is inscribed inside of, it's a little bit hard to draw this, but I think you're getting the idea, hopefully. So in this case, what's happening is my rectangle, or in this case, whatever I'm doing, notice the circle, the imaginary circle is now inside, so it's inscribed. So we have the center point of that circle, and the radius defines the distance from the center point to the midpoint of that line, okay? So these 2 methods are slightly different. Then the third method that you have is called an edge method. So if you have an object, the edge is the distance from here to here, And what that'll do is it'll allow you to define the size of your polygon, but you won't know where its center is. So the center will be an unknown, okay? So let's go back and check this out. Pretty simple to use. So we're going to go to the polygon. First thing we have to do is enter the number of sides. And if you've never done it before, I think it defaults to 4. So we're going to go ahead and make this pretty big. We're going to go ahead and type in 10 for the number of sides. So after you've done that, then it says, okay, do you want to do a center type polygon or an edge? Okay, so the default is center. So if you want a center polygon, you just kind of pick a point. And then you need to tell it, well, am I doing an inscribed in a circle or a circumscribed about a circle? And notice the inscribed option is the default. So if you just hit enter, we're doing an inscribed. So notice, here's my polygon showing up. The distance from the center point out, notice I'm increasing the radius, decreasing the radius. You don't really see the circle, but the circle is zipping around the polygon and each vertex is hitting the circumference of that circle. So let's go ahead, we're going to type a distance in here. We're going to type 5 in, okay? And you should see your polygon on the screen. And that polygon, if you click on it, notice it's all one object and it is actually a polyline. So it's a 2D polygon that's closed. Okay, did everybody get that to work?
Yep.
Okay, if you selected your polygon like I did, go ahead and hit the escape key to deselect it. And we're going to try the second option now. So the second option is center circumscribed. So we're going to use the same number of sides, so just accept the 10. We're going to pick another point right here, but this time we're going to do it circumscribed, about a circle. So notice now as you drag this out, what's happening is there's an imaginary circle that's happening, and that imaginary circle is going from the center to the midpoint of that line. And let's use the same distance. Okay, if we're going to use the same distance. So if you notice, these two guys look pretty close, but actually if I would move the one, you could see that I could move the one, and the one is a little slightly smaller. Now the angles are the same in both of them, but the line segments are different, okay? All right, everybody see how that worked?
Yep.
Okay, so
All clear.
so the other thing we can do is do an edge option. So let's check out the edge option. So we're going to go to polygon, and this time we're going to knock it down to 3 sides. So I'm going to say 3 sides, enter, and I'm going to choose edge. So you're going to pick a point, and notice that's like sticking a pin right there. So if you pull that out, notice as you pull it out, you're getting the edge is going to be bigger, it's going to be smaller kind of deal, right? See that? So we can be very precise if we want to. For instance, I could tell it I want that to be exactly 5 units long with an angle of 30 degrees with respect to x. So what I could do there is type in a polar coordinate. I could say at 5 units less than 30. And what that will do then, it will make this 5 units, 5 units, and 5 units. If I would do a distance command here, whoops. If I do a distance command, notice if I pick that point and that point, it tells me, yeah, that thing is 5 units big. What I don't know about this polygon is I don't know where its center is. So the difference is I place this by its center. Here I don't know what its center is, okay? And there will be a way to find the center of a polygon later on. A couple of years ago, there was not an easy way to do that in AutoCAD, but they've changed that. Maybe about 5 years ago, they made a little snap that'll do that for you. All right, is everybody okay with that?
Yep.
All right, so we're going to take a look at another object here. It's called the point object. So let me explain that a little bit. Now, the point object is something you're probably not going to use too much. It's kind of like a little marker. And what it'll do when you place a point, you get different looks. So I can get a point that looks like this. I can get a point that looks like this. I can get a point that is composed more of complexity. So I can have a point that has a circle and It may have a line through it like this and a line through it like this. So these guys can be complex. These guys cannot be broken apart, so there's no way to break that apart or explode that. So they just look like this, and that's all they'll ever be. There are two variables that govern how these look. One is called your PD mode setting. Okay, and the PD mode setting is the setting that makes it look like that, or like that, or like that. The PD size setting determines how big your point is. And so if we have a PD size of, let's say, 1/2 inch, that would be that setting. You can also have it either relative to the screen, or you can have it in what's called absolute value. So if you have it absolute value, as you zoom in and out, that guy's going to look bigger or smaller. If you have it set to a percentage of the zoom, what will happen is as you zoom in and out, it's always going to look the same size, whether you zoom in or you zoom out. The easiest way to get to these two guys is a command called DD, which stands for Dynamic Dialog Box P type. So you can think that stands for Dynamic Dialog Point Type, okay? So we're going to go back over here to AutoCAD, and we're going to set up our PDs first, our PD mode and PD size. If you want to delete all this stuff, let's just go ahead. We'll say erase E all, and then enter twice, okay? All right, so we're going to go ahead and we're going to type in DD rather, P type, DD P type, and hit enter. So what should pop up when you do this is this dialog box, and this dialog box are showing you selected types of shapes that you can have. So these are your PD mode settings up here, and the way they work, it's kind of weird, but this is 0, 1, 2, 3, 4, and then it jumps to 32, 33, 34, 35, 36, and then 60, 64, 65, 66, 67, 68, and then this is 96 through 100. So that has to do with a binary relationship, so that's kind of why they do it that way. And this down here, this governs your PD size. So your PD size, notice, is set to 5% of the zoom. That's because it's relative to the screen zoom. If we set it here, we can actually do it in absolute units. So what I want to do is let's set that to an absolute value of 0.25. And let's set it to this PD mode setting. So that's 0, 1, 2, 3. So we're going to go set that to 0.25 at an absolute and put it that guy and hit OK. So now as we go in and place points, now that's going to give us that look. So points we find under the draw section, and there's 3 point commands. This is your actual place points. This is called the divide, and this is called the measure. I'm going to show you how to do these, or at least that one. So go ahead and select this one called multiple point. And essentially all you're going to do is just pick a point, and as you pick points, you'll notice your points just come in. And that's about all there is to it. So when you're done, just hit the escape key. And you'll notice these guys, it's just that object, that's all there is to it. They can be moved, they can be rotated, they can be deleted, but they can't be exploded. So you can't make this thing any more than what it is. This is all it is, okay? Is that working for everybody?
Yep, that was easy.
We kind of use these for little markers, by the way, so they're not very useful that much, especially because you cannot have 2 styles in your drawing at the same time. I think that's a really bad thing with AutoCAD, but I'll show you what I mean by that. So we're going to go into the DDP type again. Type in DDP type, hit enter, and let's change that to this guy right here, which would actually be point style 99. And you might want to change this to maybe like say 0.35. So once you make those changes and you hit enter, or OK rather, you'll notice that those guys updated to that. So you can't have more than 1 point style in a drawing. And I really think that's a bad thing from AutoCAD's standpoint. They really should have a way to do it, because mappers like myself, we like to use little symbols like this to represent things like trees or fire hydrants or whatever, but I can't do that because all my points always are going to look the same if I'm using AutoCAD points strictly, okay? You guys getting the idea?
Yep.
Okay, so here's a cool thing. Let's go ahead and draw a line here. Let's draw a line like this. And there's a way to divide this thing up into a select unit of segments. So you might say, I want to divide it into 3 equal segments or 10 equal segments. So you can have AutoCAD do that, and what it does is it places a marker at whatever division point you want, but it doesn't actually break the line up, but you got this little marker that you can use to snap to. So if we go to this guy here and we select divide, what we're going to do is select this object to divide, and then it wants to know, well, enter the number of segments that you want to divide it into. So it has to be an integer number. You can't have 2.5. So you can do 2, you can do 3, you can do 10. So let's type in 5 and hit enter. And you should notice what we got were 5 divisions. 1, 2, 3, 4, 5. If you click on this, you'll notice the line is actually not broken, but what this is showing you is where the 1/5 division is. So that would be the 1/5, 2/5, 3/5, 4/5, and 5/5. Okay, now that's a pretty cool little tool, and it's nice because you can use these little guys here to snap to, and then when you get done, you can discard them. Okay, but notice again, these guys don't actually break it up; they just mark it. Okay, any questions on that? Pretty straightforward, right?
Yep.
I don't know if we're even going to use them this semester in any drawings, but you might consider that little divide thing because that's kind of a neat little trick. And so if you have an object you want to get like a 1/3 point on it or 1/3, locations, that's a great way of doing it. Okay, so let's go ahead and we're going to take a look at one more command, and this guy is called a donut. And or one more draw command. We got more commands to look at, but okay, so a donut, actually, I think it looks more like a washer myself, but what a donut does is you have basically 2 circles, one that is inside and one that is outside. Yeah, that's not too bad, okay? So what you get with this, you define the center point of the circle or the donut, and then it wants to know the distance here, which it calls the outside diameter. It calls this the outside diameter, or the OD, and the inside diameter is this distance. This is what we call the inside diameter. Now what the donut will actually do is it'll fill between these 2 lines, so it'll be filled in. But what it actually draws a polyline, and you have an arc that goes from here to here at 180, and you have a second arc that goes from here to here at 180. So if you explode a donut, what you come back with is just 2 arcs, okay? So it's kind of like the point. You're not going to use it too terribly much, although it does have one really cool thing in it. If we set the inside diameter equal to a value of 0, you can get a solid circle. Oh, one thing I should mention, that the outside diameter always has to be greater than the inside diameter. You can't have that reversed, okay? But I can have the inside diameter set to 0, and if you do that, you get a solid circle. That's probably its biggest virtue, and that's what I use it for the most, okay? So let's go ahead. We're going to erase all of these objects. So erase, enter all, enter twice, okay? So the donut is also found under this location. There's your little donut. And notice they spell it D-O-N-U-T. So that is actually, that's not the misspelled, that's how they spell it, okay? So we're going to select that. And notice it asks you to specify the inside diameter first. There is a value in place, so it automatically has that. I think it's 0.5 on the inside and 1 on the outside. So if you want to change it up, this is where you would change it. Let's go ahead, we'll just accept the inside diameter. Then we're going to hit enter for the outside diameter at 1. So now all you're going to do is just come up here and you're just going to place donuts, place a donut, place a donut, place a donut, And that's all you're getting. And again, I call it a washer. That's what it looks more like to me. So when I get done, I just hit the escape key or the enter key and it's just done. All right. So that's pretty simple. This type of donut, I mean, it might have some uses. I will occasionally use this type of donut, but I'm going to show you the other one that works better for me where I have a solid circle. So we're going to go here again. We're going to go to donut. This time we're going to set the inside diameter to 0. We're going to leave the outside diameter at 1. And notice now when you place your donut, 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 you get that solid circle. And the beauty of this is a real nice way of filling in circles. And at one time in AutoCAD, that was the only way you could do that. They have a couple other ways you can do that now, but at one time that was true. So click on one of these donuts, don't care which one. Notice what you're getting, you can't see it, but this is an arc that's running from here to here, and there's an arc that's running from here to here. And if we have that highlighted and you hit the X key and then hit enter, notice it explodes it. It loses the width, but notice what you get. There's your one arc, there's your other arc, okay? So that's how it actually creates that donut. All right, so let's take a look at one other thing here. If we check the fill out on this, let's go into the fill command again, type in fill, hit enter, turn your fill off, and then regen RE. Notice the look of your donuts. They kind of look like spokes in a wheel. So if you print that thing out, that's what you're going to get, that spoke look to this, okay? So there's your donut. All right, let's go ahead and turn our fills back on because we're gonna want to leave those on. So fill, turn your fills on, and then go ahead and regen at RE. Okay, because like I said, if you don't do that, AutoCAD will leave it that setting, and then when you plot or print or even draw, you're always going to see that unfilled look. Okay. Any questions?
Awesome.
Okay, so let's go ahead. We'll erase. Well, actually, you can leave that on because we're going to start some other things. So one of the things I want to do now is take a look at, so we've looked at P-line, polygon, point, donut. So we're going to look at these file commands, new, open, and then we got the save and the save as commands, okay? So as we look at those in AutoCAD, we would find those under the application menu. There's your new, open, save, or save as. We would also find those up here in the quick access toolbar, new, open, save, save as. You can also type in the name of the command. You can type in the word new, or you can type in the word open, or you can type in the word save. So that works as well, okay? So let's look at new. There's two ways to generate or begin a new drawing. The easiest way is to probably just click on that plus right there, and it automatically generates a new drawing for you. Okay, it doesn't ask you any questions, you just go. So you need to understand what it's using. When it opens up that drawing, it actually uses another drawing called a template file. And that template file is called acad.dwt. So what it does is it brings in certain settings automatically, like for instance, settings on your units and settings on your other objects that you might have. So you can actually have a very complex template if you use the new command. So what we're going to do is go up here to the new command. And when you do that, notice there are templates that you can choose from, but notice the default is called the acad.dwt. Okay, so that's what it uses if you just go over here and you click that guy. If you are a company that does various different things, you don't want somebody creating title blocks and setting up color schemes and all of that because that's a waste of time. So what you can do is create a template and make that your master template. And if you look down through this list, you see they've got some suggested templates down here for you. So for instance, if we go down to the bottom, there's this one called tutorial architectural. Notice if you click on that template, what it's going to do is it's going to bring in a title block for you automatically pre-created. So all you have to do then is just say open, There's your template. Notice there's a title block right there. It's set up all kinds of stuff. If you go in here and look at this, there's layers with colors. Line types are all set up. So what would maybe take a person an hour or so to set up, this has already done that for you, okay? So that's a really cool thing. The only thing about what we just did was we set that template now as the current template. So we're gonna fix that, okay? So go ahead and we'll just close that drawing. Don't save the changes. Come back to the new command and notice it says the template architectural. Make sure you set that back to the ACAD DWT, because otherwise it's not going to work right for you. And when you open it up, you'll get all that other stuff. Okay, so if you do that, we've fixed it. Okay, so it should look like that. So the new command is what you would call a productivity type of tool, and it would be something that people use in industry. But you actually are using it, particularly if you just click on that, it's actually using that template file. And literally any file that you have out there can be a template. So it doesn't really, it doesn't have to be a DWT. Any DWG can be a template. All right, so let's, we're going to close this guy. We're going to close that guy. Just if it asks you to, if you want to save, just say no. Okay, just say no. All right, so we have been working on drawings, that drawing one. So if you have that drawing one handy, go ahead and open it, okay? So what we're gonna do is open it. I'm gonna show you there's an open command here. And a little bit about this. With this open command, which is kind of cool, you can tell it where you wanna look. So mine is set currently to the desktop. So in this, it shows me any drawings out there that is be an AutoCAD file. So there's an AutoCAD file, there's an AutoCAD file, there's an AutoCAD file. Okay, those are all AutoCAD files. So if I find the one I want, I click on that. And then after I do that, I have different ways I can open this, okay? So if we go over here to the open button there, notice it drops down and you can open it as a normal file. You can open it read-only. You can open a partial to open, and you can open up a partial read-only. So the one thing about the read-only that a lot of people need to understand, if you have an open file like this, you can freely edit and save to that file, okay? So you can edit and save to that file. If you do an open read-only, what's gonna happen, you can actually save, or you can make edits, you can change it, modify it, but it will not let you save it. So a read-only, what it means is you can edit it, you can modify it, but when you try to save it, it won't let you. So what you would have to do is save it with a new file name, okay? If you have a really complex drawing, you don't want to necessarily open the entire drawing. So that's what the partials are for. You can open just a piece of that drawing. So you can do what's called a partial open or a partial read-only, okay? Now the other thing you got down here is different types of file types. If you drop that down, you can open up a DWG, which was what you normally do, or you can do what's called a standard file, DXF, or DWT, a template file. So let me explain a DXF a minute. A DXF stands for a drawing interchange file format, and that was a very important file back in the early days of CAD because, you know, back in the 1980s and early 1990s, there were probably 200 different CAD vendors out there, but you couldn't share information between them. So if I was working on MicroStation and somebody was working on AutoCAD, we couldn't share data. So the companies got together to create an intermediate file. And what this does is if I'm working on AutoCAD and I want to give it to MicroStation, my file type is a DWG, MicroStation is a DGN. So what I could do is I could save it as a DXF file, and then I could give that to somebody and they can open up the DXF file. So it's a way of translating basically from, like, say, German to French, if you will. And so that was a pretty important file type. So you can still use that. So if you select your lab one and then just hit open, you'll notice it just opens it up like that, okay? So if you guys go ahead and open that up, you'll see that. All right, did everybody get that to work for them? That has a file, and even if you don't have your lab one completed, it should open up. Did it open up for everybody?
Yep.
Okay. Yeah, but not like this.
What do you mean not like this?
I went to my DWG file, the for lab one.
Uh-huh.
If I open it, it doesn't look like this.
Oh, well, like mine.
Nah, it's not like green. Yeah.
Okay, well, because this is actually what like the master I gave you. So these are dimensions. You guys don't have dimensions on yours.
Okay.
You probably don't have that either. So in general, it just should look kind of like mine, right? But not exactly, correct?
Yeah.
Okay, that's cool. As long as you got it like that, that's good. Okay. So this file is open, and at this point you could save it. If you didn't open it as a read only, we could save it. So there's two ways to save an open file. Up here you have the save command, and then you have next to it what's called the save as. So if you want to save this file to itself, basically you just click the save, and it doesn't ask you anything, and it just saves it. Now, if you do that, you might notice down here it says QSave, and that's because the name of that command is actually QSave, which stands for quick save. It's not actually save, okay? So that's actually a QSave, but the QSave or save just saves it directly to the file you're working on, and doesn't ask you a chance or give you a chance to change a name or a location or any of that stuff, okay? So here's the thing, when you're working in AutoCAD, you should get in the habit of saving like all the time. And I tell people this all the time, and I don't do it. I'm kind of guilty of it too, but I would say probably you want to save like every 5 minutes or so, every 10 minutes. And it's real simple. You just come up here and click, come up here and click. And if you don't do that, like if you just draw like for 8 hours and you do a save 8 hours, you have the potential, like if something crashes, you may lose it before you save. So you gotta watch that. Okay, that's why it's important to save. So the other type of save is the save as. If we click on the save as, what this allows me to do is save this to a different location. So right now I'm working on the desktop, but if I wanted to, like, say, save it to my flash drive, I have a flash drive here, my passport, I could save it to my passport. And then I could save it with let's see if I put it in that file right there, that folder. I could put it to that folder. I could give it a new name down here. So instead of calling it Lab 1, I could change it. I could call it Decker Lab 1. I can also change the file format. So notice, and this is important for anybody that's working in AutoCAD, there are different formats here if you drop that down. So you'll notice there's a 2018 format, 13, 10, 7, 4. The reason we have all those formats out there is because AutoCAD is not compatible with itself in different versions. So version 21 to 18 is compatible. So if you're working on 2021, you can save your file as a 2021 file, and an 18 AutoCAD will open it up, but AutoCAD 15 will not open it up. So if you want to take it down to AutoCAD 15, you have to save it down to a lower level, like an AutoCAD 2013 file. So there's ways to do that. The only problem with that is there are certain things that may exist in 2021 that don't exist in 13, so you can lose data when you do that, okay? Notice you can save all the way down to a release, looks like 14 file. If you want to go below that, you have to save it as a DXF, okay? You would have to do is at a DXF. And the other thing you can do is you can save standards files, template files, and DXF. So those are the major ones, okay? Any questions?
What is the version of CAD we have in the lab?
The version of CAD, a good question. The version of CAD we have in the lab is 2020. Okay?
Because I installed 2020 and I'm having an issue opening up what I had last week.
It should not. What kind of issue? What do you mean?
I can't find the file on CAD.
Okay. Where did you save it? At work or at
It didn't-
school?
I saved it at school and then I emailed it to myself because I didn't have a flash drive at the time.
Okay, so where did you put that file when you emailed it?
I put it into my downloads folder.
Okay, so you should be able to, let me show you what you should be able to do here. You might want to follow me. You open it right now? You've got things open right now?
Yes.
Okay, so what you could do is if you go to open, up here, you should go to your downloads folder, okay? So in my case, I would have to go to my C drive. Let's see. It's hard to find sometimes, but it should be there. There's my downloads. And then once I open that, inside of downloads, notice there's a bunch of downloads that I've downloaded. It should be able to find it in there. Okay.
That's the main issue I'm having, is that I did get that far, but then
Yeah.
it's not showing up there.
Okay. Is it set to a DWG here?
I believe so.
Okay. Now, let me ask you this too, because there's two types of files that AutoCAD creates when you save. One
It's
is
a
BA.
DWL.
Oh, well, see, that's not actually a drawing file. Okay. That's a lock file. Okay. So what you sent was the wrong file. When you open up a version of AutoCAD, okay, so or a drawing, such I opened up this drawing, right? So
Yes.
if I tried to open up this drawing again, it'll open it up as a read only. So watch what happens. If I open that up again, see what it says? It's already in use by me. So if I say yes, these are both open. See that? There's that one and there's that one, but this one's locked. So when it's locked like this, there's a file out there called a DWL that it creates to say, hey, this one's locked. And what you sent yourself was the lock file, not the DWG file.
All right.
So you're
Now,
not, you don't have the file essentially, right? It's
Can I still submit that to you when we submit it, or?
the lock file?
Yes.
No, it's nothing. It really is just a little file that says, hey, this file's locked. That's all it
Okay.
is.
So I should probably just redo the entire lab then.
Yeah, unfortunately, that's what's going to have to happen. It's not a big deal. I'm not going to worry about timing. I mean, it might be a big deal from you from the standpoint that you did it once, right? I
Yeah.
understand that, but it's, don't worry about it in terms of me, wanting to get it like tonight or anything, okay? But that's what happens because there are DWG files, DWL files, and there's BAK files. And that's the BAK file. The BAK file is basically the same thing as the DWG file, but it's usually one generation removed, okay? But the lock file is nothing, okay, unfortunately.
All right.
All right, does that make sense though?
Yes, that makes 100% sense.
So if I looked out in the directory where these two files were right now, you'd see out there a lock file, okay? Yeah, so that's what's going on there. All right, so sorry about that, but that's the best I have for you, okay? That was a really, really good question, and everybody hopefully caught that, what we were talking about there, okay? All right, we're gonna move on if there's no more questions. I want to talk about some Zoom issues, okay? All right, so let's go back here. I'm gonna explain something. So the way AutoCAD displays things, let me show you. There's essentially three areas that you might think of three databases that it holds information in. So you have this database and this very large database, and then this represents your screen. Okay, so this is essentially your DWG file right here, and it's composed of what are called vectors. Okay, so what you have is vectors, and this is what we call vector data. This data is what we call raster data. And in a raster type data, you're composed of a system of dots essentially. And your screen, if you've ever if you've ever looked at your screen, like say with a magnifying glass, you will see that that's a bunch of dots as well. So when you draw a line in the vector database, it looks like a line, okay? In your raster, it kind of looks like that. You know what I'm talking about, the stair-steppy look. And the screen, it may not look like that, but it's also kind of jiggly like that, okay? So with AutoCAD, you're working in a vector format, and this is where your 14 sig figs are, and it's actually real numbers, but rasters are integers. So what it has to do is it has to convert your vector data into raster data. And this guy is what we call the virtual screen. So it's kind of like a buffer between your actual screen and the database itself. So after you calculate coordinate vector positions into the raster positions in the virtual screen, then it can display it on the screen, okay? So raster to raster, this is integer to integer. It's a real quick calculation to go from here to here, okay? So when you go from here to here, this is what we call a redraw. When you have to go from here to here, so if you're going like that, that's called a regen, or regeneration, okay? So this takes a little bit of time to do. If you have a really big, large drawing, you can actually see the difference between a regen and a redraw. With the computer screen, or the computer power right now, nowadays, and those things, you hardly see the difference. But back in the early days of CAD, when I was starting in CAD, if you did a regen on a drawing, you literally would have to go get a cup of coffee and come back, and it would still be chugging and regenning before it would display it on here. So when we go from virtual screen to your actual physical screen, it's a redraw. If you have to go from here to here and then back, that's a regen, okay? So I'm going to show you the virtual screen as we get into this. So let's go back to AutoCAD, and we'll just use our drawing. If some of you guys don't have drawings, what you can do is just draw a simple rectangle for me right now. Just go in, and what you can do is just go in and draw a very simple rectangle. Don't worry about its size, just draw a rectangle to represent something, and you might want to put a couple of circles on the inside just to represent your picture, okay? So that everybody, while we're doing these zooms and things, you'll be able to see what's going on. Okay, is everybody okay with that?
Yeah.
Okay, so I'm going to use this drawing right now. So if we're gonna look at what's going on here, regen versus redraw, you're really not going to see anything. So if you want to do a redraw, all you have to do is type in R and hit enter. So what you can do is think redraw just basically means refresh the screen, okay? Just refresh the screen. If you want to do a regen, you would type in RE and hit enter. And you probably didn't see any difference in the way the screen reacted, did you? Anybody see any difference?
No.
Okay, let me see if I've got a really intense drawing. Let me see if I can open up that drawing and see if I can show you that. This drawing is a really big, intense drawing. Let me see if we can show you the difference here, okay? So it's still actually, now I'm gonna do a redraw. I'm just gonna type in R and hit enter. I wanna watch the screen. You might see a little bit of a flicker, but it'll go quick. Did you see anything? I didn't see anything, right? I'm gonna do a regen now, watch it and see if it does anything. Yeah, it happens pretty quick, okay? But it used to be something as complex as this drawing. If I would have done that, it would have made a huge difference, okay? So with today's computers and processors and that, you don't see much. So, all right, so I'm gonna go ahead and close this because we don't want that one. All right, so let's take a look at the zooms, okay? So there's quite a few different zooms, and there's a lot of different ways to do with zooms. The first way you can do a zoom is using the zoom command, and that has a bunch of different sub options, okay? So if we go down here and type in Z and hit enter, you're gonna see some of the sub options. And there's actually more zooms than they show you here, but we have what's called the zoom all, zoom center, zoom dynamic, zoom extents, previous, scale, window, object, and zoom real time, okay? And the other way you can do a zoom, go ahead and hit the escape key, is if you take your middle mouse and you roll it away from you, you're doing what's called zooming in. If you roll it towards you, you're zooming out. So in other words, you're decreasing the magnification, increasing the magnification. And when you use that, that's called an antella zoom, okay? So increase, decrease, and it also makes a difference where your cursor is, because that's where the zoom originates from. So if I put the cursor down there, notice as I zoom in or out, it makes a difference than if I put it up here, zoom in or out. zoom in or out, zoom in or out, okay? So it always makes a difference where that cursor is, all right? Everybody see how that works?
Yep.
So you have quite a bit of control with your mouse. That's really a nice zoom, but you have a little bit more control when you use the zoom command. So what we're going to do is take a look at that. So we're going to type in the word zoom, Z, and hit enter. And we're going to look at these guys first, the zoom all and the zoom extents, okay? So they're pretty similar, but the difference is that the zoom all looks at your limits, your current limit setting, and your extents, and it displays them together. So if my limits are sitting right on top of this rectangle, the zoom all is basically just doing what's called a zoom extents. It's just zooming to the extent of the objects, okay? If, for instance, though, my limits were sitting over here and my extents are over here, my picture is going to look different, okay? So go ahead, you guys go ahead and do a zoom all, and your picture should look like this because I had you guys set your limits up so that they are coincident with your objects. Did everybody fill the screen like that?
Yeah.
Yep.
Now, if you guys that didn't have that lab 1 and you just drew a rectangle anywhere, it may not have done it. Okay, so for instance on this one, because I just, okay, see that kicked it off just a little bit differently. Okay, so I'm going to change something here on mine. I'm going to go into my limits commands, and I want to show you what happens if I set my limits different. So I'm going to put my limits over here, lower left, upper right. So now watch what happens when I do a zoom all. Z, enter, A, enter. So you see what's happening here? This is my extents, and my limits is over here. So what it's really doing is it's displaying both of them at the same time. Okay? Both of them are displayed at the same time. Does that make sense?
Yep.
Okay. If you do a zoom extents, that ignores your limits. It doesn't care where your limits are. It only looks at the extents of your objects. So if I go to a zoom extents, notice that is what I get for my extents. Okay. So you need to remember that probably if you had a choice, I would probably use zoom extents most of the time, because what that does is that shows you everything on your drawing as big as it can be. Okay. It shows you everything in your drawing as big as it can be. Got the idea?
Yep.
The other thing that a zoom extends very often will do, or the zoom all, sometimes they force a regen also, whether you like it or not. So you may get a regeneration happening if you do that, okay? So that's a possibility. All right, so we're gonna look at scale next. So there's several sub options for scale. Let me kind of explain that here. So when we look at a zoom scale has 3 sub options. So if we go into a zoom, and then we do a sub option scale, you can enter a number such as 2. You can enter a number with an X after it, or you can enter a number with an XP. Okay, so all of these do something slightly different. The 2 value is related to the limits. So what you can think it basically means is 2 times the limits. The X is times the current display. So what this will do is whatever your current display size is, it'll be 2 times that current display. And this has to do with paper space. So this is 2 times paper space. And we will talk about paper space in, I don't know, about 8 weeks. So it's going to be a while till we get there. And in model space, this command is invalid. So we're not going to use that tonight. Of the 2 here, this is more useful for my purposes. So I'll show you kind of how I mean, okay? So we have those 3 options, only 2 of them are active. So let me go back. Let me fix my limits real quick because that's not going to work for me. Okay, so I'm going to fix my limits equal to that. Okay. All right, so we're going to do a zoom. And notice there's a scale option. you can select that, but you don't really need to. You can just come down here and you type 2 and it knows what you're talking about. So if I type in 2 and hit enter, that is 2 times the limits. Okay? Did you guys get it to work?
Yeah.
Okay, so limits is a fixed quantity. So if I do it again, Z enter, 2 enter, there's no change because I'm already at 2 times the limits, okay? But if I go Z enter 3, that'll bring me in, okay? So once you are at a certain value of limits, it's not gonna let you change it, okay? You guys getting the idea? It's not a useful tool to me. It's not very useful. If I want to go the other way, I would type in Z and I would say instead of greater than 1, I'm going to be less than 1. So like say 0.5, that's half of the size of the limits. If I want to be equal to the limits, it would be 1, okay? So it's not entirely useful, but it's something that you can use, all right? So the one I like is the kind that gives it times the current display. So if we go into Z and we type in 2x, that gives me times the current display. So now the current display has changed. So if I go into Z and type in 2x again, notice it'll zoom in and do it again. Z, enter 2x. Notice I can keep doing that, okay? And I can keep doing it. So you can think of that as being a percentage of your zoom or your screen, okay? All right, you guys getting that to work?
Yep.
I absolutely use that option a lot. Okay, that's a good option. And so it's really, really useful. All right, let's go back. We're going to get back to a good view of our screen. So we're going to type in Z, and then we're going to select extents. That'll take us all the way back. So the other one that's really cool is this zoom object. So what this does is allows you to select an object or a group of objects, and basically it just zooms to the extents of those objects. So for instance, if I go into zoom and choose O for object, and if I choose that circle and that circle to zoom to, hit enter, notice it takes me right to those guys. That's a really cool tool. It absolutely gets you to places very quickly. So if I just want to look at one of those circles, Z enter, O for object, select that object to zoom to, and that's basically the center of that, or that's my zoom, okay? Guys seen how that one works? That's a neat one. Let's go back. Z enter, E enter, okay? So here's another one that's really neat is the window. So basically you're going to pick 2 points like that. And the size of the window will determine the magnification. So that's not going to be very magnified. This would be highly magnified, okay? The one thing about the zoom window is that you can only zoom in, you can't zoom out, okay? But you can keep zooming in. So if we go to the zoom command, notice that there is a window option. Again, you don't have to select it because if you pick a first point, it automatically knows what you're talking about. So there's your window. So if I make that my window, that's what it zoomed into. If I want to do that to if I want to do a smaller window, Z enter, smaller window. But notice you can always zoom in, but you can't zoom out. So if I need to go back, I have to use one of those other options. So to get back easily, Z enter, E enter, okay? Any questions? Any questions? Okay, so every zoom that you're doing while we're zooming in here is remembered in what's called a zoom buffer. And that's what this previous will do. When you do a zoom previous, what it does, it's kind of like undoing zooms back in time. So if I go Z, enter, P, enter, takes me back. Z, enter, P, enter, takes me back again. Z, enter, P, enter. So you can keep doing that until you clear the buffer out. and the buffer holds 20 zooms. So once you exceed the 20 zooms, there won't be anything more in that buffer. It's not a really effective way of using zooms, I don't think, unless you're just going kind of going back and forth between things. But I usually don't use that quite as much as maybe some people might. All right, let's take a look at the virtual screen. A lot of people don't know this command exists, but the virtual screen is a lot bigger than our current screen. So if we type in Z enter Vmax, okay, Vmax, and hit enter, what this is showing you is the size of the virtual screen. So it's pretty big, right? See that? What this also shows you is if you try to zoom outside of this, or try to zoom outside of it this way, or this way, or this way, that tells you that you're going to force a regen. As long as you stay within the virtual screen right now, you won't force a regen. So it can just do a redraw. Now we can recreate or recalculate the virtual screen. If we go right here and we type in regen, R-E, we just recalculated the virtual screen. So the new virtual screen is now even bigger. If we go into zoom, enter, Vmax, notice there's my current virtual screen. So I can keep kind of going back and forth and back and forth, okay? Are you guys seeing how that works? It's kind of a neat little tool. I could tell you a whole lot of users don't even know that one exists, because that was a long time ago when that came about, and they don't even have that on that list, okay? So we're going to go ahead and do a zoom all or zoom extents and bring our picture back, okay? So we're going to take a look at the real-time zoom, and it's got some virtues to it, but I don't think it's as cool as it could be as a tool. But if we go into the Z zoom, notice the actual default here is real-time. So if you want to go into a real-time zoom, you just type in zoom and then you hit enter. And notice your cursor now looks like a magnifying glass, okay? So this is a little tricky. The way you do it is if you want to zoom in, you take your magnifying glass to the bottom of the screen, left click, hold it down, and drag it towards the top, and that's a zoom in. So click, hold, drag, release. Click, hold, drag, release. If you want to go the other way, to zoom out, you click, hold, drag, release. Okay, so now I'm zooming out. Zoom in, zoom out. If you zoom it left or right, it does nothing. So it has to be up or down, okay? It does have some cool tools in it. If you right click, notice there's zoom window, zoom original, zoom extents. So if I want to do a zoom extents, I just zoom extents. If I want to do a window, this window is a little different. When I do a zoom window, I pick a point, I have to hold it and drag and then release. Okay, so again, you pick zoom window, you pick, you hold, you drag, and you release. If you are done with the zoom tool, the real-time zoom, you just hit the escape key and that'll kill it. All right. So I probably don't use realistically, I don't use the real-time zooms all that much. I use the other zooms quite effectively. And to be honest with you, the wheel works as well as anything. You can really zoom in and out really quickly with that. All right. There is a little trick to that if you double click the mouse wheel, you have to do it just right. It's kind of temperamental, but if you do it just right, 2 quick clicks, and I'm not doing it right. There, that didn't work either. You have to do it without there it went. If you just double click it just right, it'll do a zoom extents. But that's pretty hard to get to do. It doesn't always work for me. So you can say I did it about 4 times before I got it to work. Okay. So the next thing we're going to look at is a pan. There's 2 types of pans. If you just hold that middle mouse wheel down, okay, notice it looks like a hand, and now you can drag it left, you can drag it right, you can drag it bottom, you can drag it top, okay? So that's just panning it. So the thing to understand here, it looks like it's moving the objects, but it's really not. Do you notice how your coordinate system is going with you? So you're actually moving the whole picture. You're not just moving objects, because there's going to be a command called move that's going to look a little different, okay? The other type of pan is a real-time pan, and if you type in the word pan, P-A-N, and hit enter, you're in a real-time pan. Notice that hand looks a little different. If you left click, now he looks the same as he did before, okay? When you release, he's no longer panning. Hold, you're panning. Release, you're not panning, okay? And when you're done again, you would just hit escape. All right, you guys with me?
Yes.
Yep.
All right, so one more command, and then we're going to take a look at that assignment too, and we can be done here, okay? So I want to look at what's called a view, and views are kind of neat if you have a really complex drawing. Let's say you had a really complex drawing, like say the building at the college. So if you were working in, let's say, a room like we were in room 150, and then you're also working over in, let's say, the ATLC, you don't want to be panning and zooming all over the place. What you can do is you can save different views, and then you can just restore those views really easily. So just think of them like saved views or saved zooms. And so what we're going to do, let's go ahead, we're going to zoom in to a zoom extents view. And we're going to type in the word view, and it'll bring up this dialog box called your view manager. So what we're going to do is create a new view. You give it a name. I'm going to call this view A. And I can either use the current display or I can define a new window. So for instance, I can hit define window, and it just lets me select the window like that. And then you hit enter, and it saved that little snapshot. So if I want to do another one, I hit OK there. Notice it saved that view. If I want to do another new view, click another new view. Let's call this view B. We're going to do another defined window. We'll come up here and we'll select that window and then hit enter. Go ahead and OK that. So we have another window. And let's do one more. We can say zoom C, view C, define current window. I'm going to do it around the title block. Enter that. OK that. All right. So now these guys are saved. You can apply those and then hit OK. So you can do a couple things with those views. I can actually open the drawing with those views. I can plot those views, or I can zoom with those views essentially, or open them. So if we go back into the view command, go into the view command, click on A, and then tell it to set it current, apply it. Okay, notice what it did. If we go back into the view, view B, set it current, apply it. Okay, and it's finding those views for me and just generating them really quick. Set current, apply, and you're good to go. So on a very complex drawing, that makes a lot of sense. On a drawing such as this, it probably doesn't. Okay, you guys get the idea?
Yes.
All right, awesome. Okay, so that's the lecture material that we needed to get into today, right? So we'll see if there's any questions. I can take some questions right now. Anybody think of anything as we were talking, or about anything that we've gotten into?
Particular.
Okay. Well, what we'll do then is let me go to the Blackboard site, because I don't think this is open for you guys yet. So I need to make sure, oops, I need to make sure it is. So let me see something here. That goofy thing. Yeah, I need to close that. Get that closed. Okay, so let me see. Let's see. All right. I think this is your Blackboard site. Let me go to weeks. So I have your week 2 folder open, but I don't have your assignment. So let me go ahead and open this assignment. So see if you guys can get into your assignment 2 yet. I'm going to go ahead and permit users to do that. Okay, I believe, see if you guys have your assignment 2 available now, okay? I'm going to go ahead and stop the, I'm going to stop the, or pause the